Hey guys, this is the last video in our unit over square roots, and in this video we're going to look at monomial square roots, which simply put are square roots that contain variables. So let's look at the first four here, and I'll give you the basics of how to simplify square roots with variables. So the square root of x squared, for instance, that would be whatever variable times x gives you x squared. Okay, what variable times itself would give you x squared? Well, we know x times x is x squared, so the square root or radical of x squared is just x. For number two, radical m to the sixth is basically asking what squared gives you m to the sixth. Well, if you square m to the third power, you know from our exponent rules that m to the third squared would be m to the sixth. So that means radical m to the sixth is m to the third. Number three, radical 64p to the fourth, that's asking what squared would give you 64p to the fourth. Well, there's two parts to that. We know that 8 squared gives us the 64, so there would be an 8 in our answer. And we know p squared is p to the fourth. So radical 64p to the fourth is 8p squared. The last part, the last one here, number four, radical 49a squared b to the sixth c to the fourth. What do you need to square to get this 49a squared b to the sixth c to the fourth? Well, 7 squared gives you 49. A squared is a squared. B to the third power is b to this. When you square it, you get b to the sixth. And c squared is c to the fourth. So the answer to this is 7ab to the third c squared. Notice every time when we were taking the square roots of our variable powers, we were simply dividing the exponent by 2. Okay, x squared, if you divide that exponent by 2, you get x to the first. M to the sixth, if you divide that exponent by 2, you get m to the third. C to the fourth, if you divide that exponent by 2, you get c squared. So that's basically the trick for how to simplify radicals with variable powers in them. But what we're really doing is, again, we're thinking about what are you squaring to get that original part under the radical. So it's only possible to take the square root of variables with even exponents. Okay, and all of the variables in 1 through 4 had even exponents. Now in the rest of these examples, I'll show you how we can simplify variables that have odd exponents and what we do with those. So take, for example, number 5. We have radical y to the fifth power. If I try to divide 5 by 2, like I was talking about in 1 through 4, I'm not going to get a whole number. 5 is not divisible by 2. So what I can do is I can split this up by taking y to the fifth and making it y to the fourth times y to the first. And of course, this is a radical y to the fifth, so I need a radical here and a radical here. The reason I do that is because now that I have a radical y to the fourth here, now that I have an even, I know that radical y to the fourth is just y squared. So I can rewrite that as y squared. But radical y to the first just is that. It's radical y. So that needs to stay. So my simplified answer here, when I have an odd exponent, is going to have a radical. It's y squared times radical y. For number 6, I can do the same thing with my b power. My a has an even exponent, so I'm going to leave that alone. But my b, I have an odd exponent, so what I'm going to do is I'm going to rewrite this as radical a squared b squared, and because I'm taking one exponent away from this b to the cubed, I need to put it back over here, and so I'm just going to make this a b squared times a radical b. Notice that this is a b squared and a b to the first, so they still add up to 3 if I were to put those back together. But now I can take this first radical and I can simplify this. The square root of a squared is a, and the square root of b squared is b. So this becomes ab times, this is just a radical b here at the end. Okay, for number 7, I have radical 45 n to the 4th. So I'm going to split this up into the number part and the variable part just so you can see what I'm doing here. We already know how to simplify radical 45. I need to think of a perfect square that goes into 45, and that would be 9. So I can make this radical 9 times radical 5. But radical n to the 4th, that's an even exponent, so I can just simplify that down to n squared. So now I have radical 9, which is just 3, times radical 5 times n squared. And my final answer is going to be this. It's going to be 3 n squared radical 5. Whenever we're writing our answers, we always put whole numbers first, followed by variables, followed by the radical part. So 3n squared radical 5 is the correct order for how to write our answer. Okay, let's do that now for number 8. Radical 81 c to the 7th d to the 4th. So I can split this up into my radical 81 and then my radical c to the 7th d to the 4th. But because this exponent on the c is odd, I'm going to rewrite that as a c to the 6th and then take that c to the 1st and put it out here separately. So really this is c to the 6th d to the 4th, that radical times radical c. So let's simplify now. We know radical 81 is just 9. Radical c to the 6th would be c cubed, and radical d to the 4th would be d squared. So I have c cubed d squared here, and then at the end I just have this radical c. So my final answer is 9 c cubed d squared radical c. Number 9, radical 49 a cubed b to the 6th c to the 4th. So we have our radical 49. We have a radical a cubed, so I'm going to write that as an a squared and then times a radical a to the 1st separate. And then my b and c variables both have even exponents already, so I'll keep those as b to the 6th and c to the 4th. So now radical 49 is 7. This becomes a b to the 3rd c squared. Again, we're thinking about dividing each of these exponents by 2 and dropping the square root sign. And then at the end we have that radical a. So final answer, 7 a b cubed c squared radical a. Number 10, radical 8x to the 6th. So I can make this radical 8 times radical x to the 6th. Radical 8 is divisible by 4, so I can make this radical 4 times radical 2, which just becomes 2 radical 2. And then radical x to the 6th is just x cubed. So I have 2 radical 2 times x cubed, and the order I'm going to write that in is 2 followed by my x cubed followed by my radical 2. Radical 63 x squared y to the 5th z squared. So I have my radical 63 here. I have radical x squared. I have a y to the 5th, so I'm going to make that y to the 4th here, and then separately a radical y to the 1st, and then I still have my z squared here. So let's simplify now. Radical 63 I can split up into radical 9 times radical 7, which just becomes 3 radical 7. For my middle part here, this becomes x y squared z, and then I have a radical y at the very end. So my answer, I have a whole number of 3. My variables are x, y squared z, and then I have two radicals being multiplied at the end. You can always put two radicals being multiplied back together as one radical. Okay, you're allowed to multiply radicals together and make them one radical. So radical 7 times radical y just becomes radical 7y at the very end. So this is how I write my answer. Number 12, radical 68p to the third. So we'll make this radical 68 times, my exponent is odd on the p, so I'll make this radical p squared, and then times a radical p to the first. Think about the largest perfect square that goes into 68, and that would actually be 4, so I can make this radical 4 times radical 17 is how many times it goes in. Radical p squared is just p, and at the end I have a radical p. Radical 4 is 2, so this becomes 2 radical 17 times p times radical p. So in the end, I have my whole number 2, my variable p, and then when I multiply those radicals back together, it gives me radical 17p. Okay, two more to look at. 13, radical 72 m to the third n to the 8th p squared. I want you to pause the video and try this one on your own. Once you think you have an answer, click play to check it. Okay, if you did this one correctly, then hopefully you split up radical 72 and then the rest of your variables in the radical. And m cubed means you need to take an m squared here and then an m to the first out here in its own radical. You can keep the n to the 8th and the p squared since they're even exponents. Radical 72 you can split up into radical 36 times radical 2, which becomes 6 radical 2 at the end. This middle part gives us m n to the 4th p, and then my last part is just radical m. So my answer is 6 m n to the 4th p radical 2m. Okay, number 14. Again, I want you to pause the video and try this one on your own. Once you think you have an answer, click play to check. Okay, for this one, I'm going to split up my radical 252 and then the variables in the radical. I have an x to the first, which I can't really do anything besides just leave it as x to the first. I have y squared, which is even, so I'll leave that. And then my z cubed, I can make z squared and then times a z to the first out here. Radical 252, thinking about the largest perfect square that goes into 252, if I use my calculator, I find it's 36. So I can make this radical 36 times radical 7, which just becomes 6 radical 7. Inside this square root, I can't take the square root of x and simplify that any further, so I'm actually just going to write that off to the side here. Okay, radical x to the first is just radical x. But I can simplify this part. Radical y squared is y, and radical z squared is z. So I have a times yz here in the middle, and then since I moved my radical x over here, I already had my radical z. This part here just becomes radical xz. So my final answer is my 6 times yz, and then underneath my radical, I can take this radical 7 times this radical xz and get radical 7xz. Alright, if you had any questions over this video, make sure you have those written down so that I can address those the next time I see you. Until then, have a nice day. You're all wonderful people, and take care.